Cool. Okay. So hopefully you can see my sheet here and you can hear me okay. As a reminder, your blueprint is covering these things. So you need to, just like you did in 110, you need to do your household measurements, converting between metric and household. You need to know how to do conversions for weights, primarily pounds to kilograms. You're going to have an intake question where it's that question where they're going to ask you, your patient receives, these liquids and or solids, and you need to know how to convert from cups and ounces or cups and quarts and pints into ounces and then to milliliters. Um, Oral meds are usually pretty straightforward. That's just how many tablets or how many milliliters you administer. Um, the injectables are basically calculated the same way as oral meds. It's just when it's an injectable, just know you're administering milliliters. I think what's new for you guys this semester is what I've highlighted is the IV flow rate calculations. And so the IV flow rate calculations that's going to be new for you is going to be calculating ml per hour as well as calculating um, drops per minute. And so we'll go through a couple examples of that. And then there might be some additional, when they say complex dosage calc problems, what they mean is that they might give you the patient's weight in pounds and ask you to convert the patient's weight in pounds to kilograms. Well, I mean, they won't tell you that. They'll just tell you the patient weighs this much, and then you just have to do one extra step. So sometimes they're called two-step, and you can see that in the parentheses. It says two-step, or sometimes it's just called a complex problem. Okay. So we'll just go over a couple things. These are some helpful notes. Make sure you know what is considered fluid and how to calculate the fluid. One of the things that you will run into when you're not entirely certain about that is like just you might get caught up on like the chunky soups or like pudding, things like that. Those are considered solids, but what can be confusing sometimes is jello, ice cream sometimes, right? Because if you've had ice cream, you're like, I can bite into ice cream, but it'll melt, so it's liquid. Um, your drinks, obviously, and then ice, right? Ice, you're gonna do its volume once it's melted, and so it's gonna be half. So if they tell you 8 ounces of ice, then just know that that's actually 4 ounces. So there's some nuance there. I think you kind of got introduced to that in 110, so that shouldn't be a problem. This is just a review. So all this is in Professor Geyer should have sent you out a PDF that has links. I used to use a OneDrive link, but now I use a Google Drive link. So you should have access to this particular sheet. I just renamed it to 26 fall, but it's the same as the 26 spring and the 25 spring. I haven't changed it too much other than adding some things. Okay. But make sure you know your conversions. Um, Sometimes this, like the 1 cup, people sometimes will use 250 ml or 300 ml, or the pint, they'll use 500 ml. They expect that it's 240 and 480. Okay. Okay, yeah. So let me so I saw your thing. If you email me, I'll put my email, um, and then I'll send you the PDF, the PDF that told you like or that should tell you the times. And like I said, Professor Geyer should have sent that out to you guys. So but I'll just email me and I'll send it back to you after this review session so that way you can go through it. All right. And then as a reminder, your basic conversions, you don't really use too much length measurements. I have not seen you using pounds to ounces. You do go from pounds to kilograms. You do milligrams, micrograms, milliliters, and liters and grams. So those things are pretty straightforward. One of the things that you want to remember is when you're doing basic conversions, don't round. So like if you are, converting, 70 milliliters to liters and then you get 0.07 liters. Excuse me, that's your answer. Don't convert it to zero point 0.1. That's that they're looking for you to make that mistake. So just we'll go through some examples of that and we'll see that. So let's look at some of the practice questions because that's I know what a lot of people are probably most interested in. And what I'm going to do is I'm going to zoom in on this so that way we can see it a little bit easier. At least I can see it a little bit easier. So these should be pretty straightforward. Um, you're just converting milligrams to grams. At Allegheny campus, we've always told our students to show their work. I don't know to what extent that means. I'm not the one who grades the tests. I just kind of relay the information. And sometimes you're taking this test online, and so there's nowhere to show your work other than your scratch piece of paper. But like sometimes showing your work is as simple as, you get um, your uh, decimal here, and then you're just like, okay, I know I need to move this 1, 2, 3 to the left, and then you put your answer as the 0.375. So you put your answer down, and all you showed was moving the decimal point. Now, some people don't like to move the decimal point. That's not a requirement. You can also, especially if you confuse these, just set up a conversion factor. So those of you who have watched any of my videos before know that I am big on conversion factors. And so you should already know that 1 gram is the equivalent of 1,000 milligrams. And then that reminds you, like, do I multiply? Do I divide? And so this is all supposed to be like over the top. I know I'm not writing even yet, so just I'm a little bit rusty on using my pencil here. Um, but 375 times 1 divided by 1,000, and then you get that answer of 0.375 grams. Now, oftentimes where students make this mistake, and it's happened at all the campuses, is students are like, oh, if it's a number less than 1, I'm supposed to round to the nearest hundredth. And so you go in and you write 0.38, and then they tell you no. So when you're doing just a basic conversion, when you're going from milligrams to grams, grams to milligrams, micrograms to milligrams, or vice versa, do not round. Whatever the number is, whatever the answer is, that's your answer. Do not round that answer. Now, if we are going from something like milliliters to ounces, now we're going from metric to household. So we're going in a different direction. And there might be a point or a reason to actually convert or you might need to round to the nearest tenth when you're doing something like that. So let's take a look at this conversion. So what you're supposed to do is, and again, you can do this any variety of ways, but you don't have like a table, you don't have a smart calculator where you can just convert milliliters to ounces. So it's helpful to just walk through and practice how would you set up something like this. And so one of the ways you can do that is by knowing your conversion from milliliters to ounces. And if you recall, 1 ounce is the equivalent of 30 milliliters. Now, this is not going to be an even number, and that's somewhat intentional. And what we're going to do is we're going to take our calculator, if I can find mine, 275 divided by 30, and I'm going to get 9.16 repeating ounces. So we're done with milliliters, and I'm going to get 9.1666. It just keeps repeating ounces. So we don't want that as an answer. So that's your clue to round. And if you have a number that's greater than 1, you round to the tenths place. Okay, that's at least the blueprint guideline. So if the number is greater than 1 and you're supposed to round to the nearest tenth. So this would be 9.2 ounces. So there's really only 2 scenarios where you do not round. Um, it's when you're converting, like when you're going metric to metric conversions, or you don't use a rounded answer or a rounded part or rounded to the decimal point for when you're doing drops. And we'll talk about that in just a minute. The final thing, so when you go from pounds to kilogram, it's the same thing. So now you're going household to metric. Okay. So you're going to take your 135 pounds and then you're gonna make your conversion. Now, I personally, I just go ahead and just divide by 2.2 because I've been doing that for so long, even before, nursing, like it just, or even like just learning science. That was like the first kind of big conversion I ever learned, I guess. So just if you just take 135 divided by 2.2, that's perfectly fine. But if you need practice with setting that up, this is how you would do it. So you take 135 divided by 2.2. And then again, this is your clue that you're supposed to round because you're going to get 61.3636 repeating. So it just keeps doing that, kilograms. That's not what they want. They want you to look at the hundredths place, and then if it's 5 or greater, round up. If it's 4 or fewer, then don't round it. Just leave this number as it is. So then your answer would be 61.4 kilograms. All right, so those are kind of like the warm-up questions if it's been a little bit since you've done some of these things. Um, let's work through, this is more converting. Let's walk through this or work through this scenario here for the fluid intake. So the first thing I'll recommend that you do is just write ml down here because you are supposed to know that that's what you're calculating, that you're calculating milliliters. You're not calculating ounces, you're not calculating cups or pints. Remember, when we are in healthcare, we're using the metric system. Okay. So milliliters is what you're calculating for. Okay. So it's not going to tell you total fluid intake in milliliters. It's going to say total fluid intake, and you need to know that you're converting it to milliliters. So sometimes it'll tell you this little piece of information that you have a glass and that glass holds 8 ounces. Okay. So if it tells you it's a half glass of orange juice, then that would be 4 ounces. Then we have 10 ounces of coffee. We have a turkey sandwich, so that's not liquid. Okay. Jello. Is Jello a liquid? The answer to that is yes. Even though it's a semi-solid, the majority of Jello is liquid. So if you've ever made Jello, or if you go on and you can look at the directions for making Jello, you dump in a packet and then you add a bunch of water to it and let it sit in the refrigerator till it congeals. And then you have your gelatin. So it's the protein in the gelatin that causes it to be firm, but it's liquid. Okay, so we need to know that. Then we have a half pint of chocolate milk and a half quart of chicken broth. Okay. So one way that I just try and keep these things in mind. So I think a pint is 2 cups. So a half pint of chocolate milk would be 1 cup. Same thing for a quart of chicken broth. I think there's 2 pints to a quart. Now, if I'm saying anything wrong, please correct me, but I'm pretty sure that's right. And I'm going to double check because it's been a minute since I've worked with the cups and the ounces. So I'm just going to double check that just so we're on the same part. Yeah, so 1 cup is 8 ounces, 1 pint is 2 cups, and 1 quart is 2 pints or 4 cups. So let's come back to this. Okay. Now, the other thing is I know, and hopefully you know, that 1 cup is equal to 8 ounces. Okay. And then if a half quart, which is 1 pint, is 2 cups, then that would be 16 ounces. So what I'm doing right now is I'm just going to collect all the ounces together. I'm going to add them all up, and then I'm going to multiply by 30 because that's how many milliliters there are per ounce, which is why I'm doing all this. So I'm going to add these up. So I have 4 plus 10 plus 2.5 plus 8 plus 16. So I'm going to add all those up. I just wanted you to know what I was adding in case it wasn't intuitive, but it's 4 plus 10 plus 2.5 plus 8 plus 16, and I get 40.5 ounces. I'm going to take that 40.5 ounces, and I know that 1 ounce is 30 milliliters. So I'm going to take that 40.5 and multiply it by 30. And when I do that, when I multiply those two things, I get, oh, okay. Yeah, but as long as you're getting the same answer, that's really what it comes down to, right? So as long as you're getting the same answer, but you're right. Like sometimes it is like it's sometimes it's nicer just to do the one multiple instead of doing it every single step. So sometimes, and actually another student, sorry, this is supposed to be milliliters. So another student actually gave me that advice. Okay. They actually said, "Oh, I just calculate the ounces." So, I learned from you guys as much as you guys might be learning from me. So, anyways, now you might be sitting there going like, "Oh, should I convert that to milliliter or to liters?" No, because they specifically want you to calculate the milliliters. Plus, you probably aren't going to get this big of a volume in this particular meal. Okay. But if you sit there and think, I mean, actually, that's quite a bit of fluid for a single meal. Most people will have a hard time drinking a liter of water in a day. So not you guys. So you guys are good at hydrating. All right. Any questions on this? Remember, if they give you ice, like if they tell you 10 ounces of ice, then that means it's 5 ounces. Okay. All right. I want to get to some of the newer stuff because this is stuff that you should be new this semester because I don't think you did any of this last semester, at least not on the 110 test. So I'm going to come back to these couple questions. I want to start with one of these ones without a drop factor. I want to start with this Ringer's lactate question. So I'm going to start with this one here. And so the reason I'm starting with this one here is because a lot of times I like to just kind of show you what the progression of the infusion rate type questions are. So you're going to see a question that's going to be similar to this, where it's going to ask you to you're going to take your patient's going to be ordered to receive 400 milliliters of a substance. So at this instance, it's Ringer's lactate over a period of time of 5 hours. And the question is, what are you going to set the rate on the infusion pump to? So there's actually not much of a math involved with this. It's more about the setup. And what I mean by that is what they're actually asking you to do is they want you to calculate the rate, which is milliliters per hour. They just want to know how would you get to milliliters per hour? Okay. So how would I get to milliliters per hour? I'm going to take my milliliters. I'm going to put it over my hours. And then I'm going to reduce. So I'm going to take 400 divided by 5, and that'll give me 80 milliliters per hour. So they didn't tell you how much Ringer's lactate was like available. Um, they didn't tell you like to go check on it or anything like that. They didn't say like, start time, finish time. What they want to know is, can you figure out what you would plug into the infusion pump? And this is what you see next to your patients when you're doing your clinical rounds, right? They're attached to an IV and they have numbers there, and then sometimes they'll have two different things. I think they even can have three, but they'll have like their primary infusion, then a secondary infusion, but they're all going to be calculated individually. So it's not like you need to know all the factors of each individual infusion, at least for dosage calc wise. You just need to know what you're supposed to set the pump for that particular medication. So let's look at this one right here. Okay. So it's basically the same question, but now it's saying 200 milliliters over 1.5 hours. So what am I going to do? Now, this one actually tells you what would you set the infusion pump to in milliliters per hour. I don't think it's going to tell you the units on your test, which is why I'm reminding you to make sure you know what you're looking for. But I'm just going to take the 200 milliliters divided by 1.5 hours sometime, or and then so 200 divided by 1.5, and I'm going to get, now this is where I'm going to get something where there's like repeating numbers. I don't think you're going to get an answer like this, but if you do get an answer like this, technically, if the infusion pump allows you to do it, you can round it to the nearest tenth, but in reality, it's probably going to be the whole number. So the reason I'm talking the way I'm saying this and why I'm writing three different answers is because I think this is what would be the correct answer in this instance. Um, but um, if your instructor tells you to round to the nearest whole number, or more than likely, instead of doing 200 milliliters over 1.5 hours, they'll do 200 milliliters over 2 hours, and then it's just 100 milliliters per hour, and then you don't have to worry about rounding, is the most likely scenario. But if they give you this, I think you have a good argument for going in and calculating the flow rate. So okay. The next thing is, I thought Professor Guy was going to join us. The next thing is there might be another type of example where it might ask you to calculate how many or how long an infusion might be running for. So in this instance, we know the volume of our dextrose 5% water, it's 250 milliliters, and we know the flow rate, 100 milliliters per hour. And so we already know what the infusion rate is. We want to know how long will it be infusing for. So this is where you need to be a little bit crafty and know how to manipulate the information. And this is where dimensional analysis really kind of helps out. And so what we're going to do is, or at least what I'm going to do is, I always like to start with what is my total volume? So it's 250 milliliters. And what I'm looking for when it says how long, right? We're looking for time. And so when I'm figuring out like how to set something up dimensional analysis, I always start off with what am I looking for? And I'm looking for time. And the time that I have is the hours. What am I trying to get rid of? Trying to get rid of the milliliters. So that helps you to orient where you put what numbers as they kind of go into these equations. That way you're not guessing. And then we can take 250 divided by 100, and then I'm going to get 2.5 hours, which is 2 hours, 30 minutes. I don't know that you'll see this question, but I've seen it. I've seen it as an ATI question. I've seen some other in on other tests. Sometimes they'll ask this question. Sometimes they'll ask it where they'll say, you know, you start your shift at 7:30 in the morning. Um, the you have a patient that's on an infusion or is on with an infusion rate of 125 milliliters per hour. When you come in, it's like 40, or there's 40 milliliters left, and they want to know like when you what time would you change it? Like, it's the big thing is just, can you do this? If you can calculate the quantity and then how long it'll last for, and then you can just, once you know how long it'll last for, then you can say like, oh, okay, if I checked it at 8 a.m., 2 hours and 30 minutes later would be 10:30 a.m., right? So that's this way. When they might ask you to do it in military time. But okay. Let's see here. Now, sometimes they might give you information where they give you milliliters, which you're used to seeing, but it might say minutes, right? And so sometimes that can throw some people off because we're still looking for ml per hour. Even if it doesn't tell you to look that to calculate ml per hour, that's what you're calculating whenever they're asking for a typical flow rate or infusion rate. So what do I do? Again, I'm going to take my 240 ml, this time over 40 minutes. Now, if I calculate this out, I'm going to get my milliliters per minute, but I don't want that. I actually want to convert minutes to hours, right? So again, if you ever forget, write your units first, right? I'm crossing that out. So if you're ever somebody who multiplies when they should have divided or divided when you should have multiplied, it's because you're starting with the numbers and not the units. Start with the units first. The units will tell you where the numbers go, not the other way around. Okay. So that way you're not thinking, oh yeah, there's 60 hours in 1 minute. That doesn't make any sense. There's 60 minutes in 1 hour. So when we do that calculation, 60 times 240 divided by 40. Now I'm going to get big ugly number of 360 ml per hour. And then you could do the same thing for this. So I'm not gonna go through every single one of them. I just wanted to highlight a few the different variations and kind of what they look like. Um, Yeah, and you can even see this is another scenario, right? So 750 milliliters, 4 hours. What would you set the infusion rate to? So hopefully we're getting it. All right. Now, sometimes it'll ask some additional information, like instead of wanting to know the flow rate, it might actually want to know the flow rate, but in this instance, they might want to know specifically the type of flow rate known as drop rate. So, what is flow rate? Flow rate, so when we say flow rate, that means ml per hour is like the main thing, okay? Milliliters per hour. But it could also be drops per minute. This is specifically referred to as the drop rate, but it's a just a different type of flow rate, which is why when it says what is the flow rate, you need to pay attention. Are they asking for ml per hour or drops per minute? So the question is, or to answer that question, there's usually a clue. And the clue is if they want to know the drop rate, they're going to give you the drop factor. If you want to be extra specific, you could actually do both the ml per hour and the drop rate. And then that way you have them both covered and then you can calculate them both. And I'll show you what that looks like to do both those things. Okay. But if it gives you a drop factor, then the drop factor typically indicates, okay, we're going to do a drops per minute calculation. What is drop factor? When we see that word drop factor just means drops per milliliter. And that is specific to the um, that is specific to the um, tubing that's being utilized for administering the drops. The other thing to be considerate of and understand is that when you're calculating drops, you cannot give somebody a partial drop. You have to give them the full drop. Okay. So there is no such thing as a partial drop. So all that stuff is out of the way. Let's go through this and look at this question. So it says administer gentamicin 30 milligrams in 250 ml, dextrose 5% water in 2 hours, and the drop factor is 15. What is the flow rate? So the first thing I'm going to do is I'm going to calculate the flow rate. Okay. So remember, I only need two pieces of information to calculate the flow rate. Excuse me. I need the volume and I need the time. Do I need to worry about the strength of the medication? Not for this calculation. Okay. Do I need to know that to make sure I'm administering the correct medication to the patient? Absolutely. Okay. But for calculating the rate, I don't need to know the strength of the med. I don't even need to know the total volume. I just need to know how much I'm administering and in what period of time. So when I'm calculating my flow rate, I'm going to take my 250 ml, 2 hours, and I'm going to reduce that to 125 ml per hour. So that would be my standard flow rate. But what about calculating a drop rate? So there is a nice little formula for calculating drop factor. And that is you're going to take your flow rate times the drop factor, and that will give you your drop rate. The flow rate is typically in mil per hour, but it could be in mil per minute. The drop factor is always going to be in drops per milliliter, even if it doesn't give it to you. And then your drop rate needs to be in drops per minute. If you have it in drops per hour, you're going to be given like 1,600 drops an hour, which is just a ridiculous number to write down. They want to know how many drops should it be coming out every minute. So extrapolate that out over an hour, that's going to be a lot of drops. So we have 125 milliliters per hour. I'm going to rewrite my flow rate as instead of hours, I'm just going to convert hours to minutes. And the reason I'm doing that is because I know that I'm looking for drops per minute. So this saves me a step. So I don't have to do an extra calculation. You already know that 1 hour is the equivalent of 60 minutes. So I didn't even do any kind of conversion here. I just substituted. Then I'm going to multiply by my drop factor. My drop factor is 15 drops per ml. Remember, it may not tell you what the units are. That's why I'm writing this down. So just make sure you know that when you see drop factor, it's drops per milliliter. And then before I do any kind of math, I look at my units. Before I do any calculation, I can see that once I'm done, I have drops and I have minutes as my remaining units. And so I'm good to go. So I'm going to take 125 times 15 divided by 60. And here's a good example. I'm going to get 31.25 drops per minute. So here's the thing. I can't give somebody a partial drop. They either get a drop or they don't get a drop. So there is no partial drop. So what do we do for that? We round, but we're going to round to the whole number, not to the 10th. Okay. So we just look at the 2.5. If it
Dr. Hart, before we continue,
hold,
I'm sorry.
hold on one second. Let me finish my thought here, please. So once we if it's 4 or fewer, then we drop it. Okay. So we don't include it. So your final answer for this one would be 31 drops per minute. If it were 31.5 or 6 or 7, then you would round it up to 32. Go ahead, Edith. What's your question?
I got confused about the minute. You said 60 minutes. It's not 120 minutes because it was 2 hours. I
It
don't know.
was
I got confused there.
it was originally, yes. So that's correct over here. But what I did is I reduced it because um when it asks for the flow rate and it's not being specific, I was
Okay.
suggesting that you might want to put both answers, meaning you might want to put the flow rate and the drop rate as your answers for this question, just so there's no question that you know how you're calculating it.
Okay, I saw my mistake. Thank you.
Okay, you're welcome. Now, thanks for pointing that out. Now, just so you know, like, yes, I would do what was suggested there. Like, the way I would classically set this up is I would take the 250 ml, and then instead of 2 hours, 2 times 60 is 120 minutes. And then I would just go right into multiplying by the drop factor, which is what I think she was asking about. And then we get that again rounded 31 drops per minute. So there, one of the things you'll learn with me over the years, and when you watch the YouTube channel, and if you watch the other versions of these reviews, you'll see that I do a couple things in a couple different ways because sometimes it makes more sense in a different context. And then what Edith was doing was going right to drops per minute, which is how I would answer this question, to be honest with you. But I just wanted an extra practice and also to show you that we can do this a couple different ways. So, um, We have the same kind of scenario here, except I added a few extra numbers. Again, I don't think you're going to have to worry about this, but I don't know what ATI is going to do to you. We have 45 milligrams in 75 milliliters, 25 minutes, and then every 8 hours, and a drop factor of 10. So there's a lot of numbers in here in this particular question. So, and then it asks, what is the flow rate? So let's just focus on for this one, flow rate. Let's just focus on drops per minute. So as a reminder, I need two pieces of information. I need to know the flow rate and I need to know the drop factor. So we got the drop factor. So that's 10. That's done. But my flow rate, I have volume here, but then I have two times. I have 25 minutes and I have 8 hours. So let me explain how I would read this. The over 25 minutes every 8 hours just means that you're going to repeat the over 25 minutes every 8 hours. So three times a day, you're going to do this 25-minute infusion. So when you're calculating your flow rate, you don't care about the 8 hours, just like you don't care about the 45 milligrams. Okay. Isn't now we have something we can work with that's not so overwhelming as far as the actual quantity of of information. So what am I going to do? I'm going to take my 75 milliliters over my time, which is 25 minutes, times my drop factor, cross out mLs. I'm left with drops per minute. Now I made this easy, right? So 75 divided by 25 is 3 times 10. So this is a nice even 30 drops per minute, which is most likely the type of question you're going to see, where it's kind of straightforward like that. All right. And again, another similar type of question, right? So we could ignore the 75 milligrams, we could ignore the 6 hours, and then you're just going to take your volume over time, multiply it by 5, and then you're going to get your drop rate. So hopefully it's coming together. Once you see it a couple times, and then I leave a couple of these for you to practice. This is one that we use at Allegheny campus. So we have a patient that's receiving Solu-Medrol 200 milligrams IV, received from the pharmacy in a 250 milliliter bag, and it's going to infuse over 50 minutes with a drop factor of 15. No other IVs are running. What is the correct flow rate? What is commonly missed on this question is students try to incorporate that 200 milligrams. Again, when we're talking about flow rates, we don't care about milligrams. Okay. All I care about is the 250 ml, the 50 minutes, and then the drop factor. I'm going to take my 250 ml over my 50 minutes times my 15 drops per ml. You don't have to write these out the way I do. The main reason I do is just so we can see that we're crossing them out. Sometimes if you accidentally put the ml up here, then you can't cancel them out when they're on the same when they're both in the numerator. And so we want to make sure we know where these things go. Anyways, so I try to make this easy, right? So 250 divided by 50, I think is 5. Right, 5 times 15. And so again, we have a nice even 75 drops per minute. Now, if you were to accidentally leave this in hours, just so you know, your answer would be like 4,500 drops per hour. So nobody's getting 4,500 drops per minute. But 4,500 drops per hour, 75 drops per minute, that seems to be a little bit more in line. That even seems high to me, but I also don't know, what each of these things, like what quantity it needs to be. I just want to see if there's any other. That was just another one of those. So those are the flow rate type questions. Just practice them. you should have access to a blank version of this review sheet. Um, and then if you didn't get it, I put my email in the chat. If you didn't get it, I'll email you the link so you can have access to the Google Drive. Um, these are examples of the two-step problems. Okay, so let's look at one of these. I'll do the second one here because I think it's one that I made up, but it's kind of messed up. So let's read through this. It says we have an MD that's writes an order for ibuprofen, 3 milligrams per kilogram by mouth every 6 hours for pain. Child weighs 73 pounds. Pharmacy dispenses you with 50 milligrams per 2 ml ibuprofen. And then we want to know how many milliliters to administer for the dose. So if you think about it, if you have a child might be getting a liquid version of a medication, even something like ibuprofen, as opposed to something they're swallowing, or it might be a chewable. But in this instance, they tell you that it's the ml. Okay. And one way to remember that too, if you see that your order, or I'm sorry, your available has milliliters listed, just know that that's the unit you're going to be using for administration is milliliters. You can't administer milligrams to somebody. It's either a tablet, a milliliter, a cc, milliliter per hour, drops per minute. Like it's a volume that you're giving them, or a tablet or a capsule, not an mg. All right. The other thing, and this will come in handy, sometimes there'll be a safety range for when like the 6 hours. So like when you are in third semester, you'll take pediatrics, and then they'll start talking to you about like, is this a safe range? Like, can it be administered 4 times a day, or is that not safe? So, all right. So what we're going to do is we're going to figure out what this kid needs. And the first thing we're going to do is we have pounds, but we have an order in kilograms. So we need to first convert pounds to kilograms. So I'm just going to take my 73 pounds divided by 2.2. I know that looks like 7316, but I promise you that's supposed to be 73 pounds. So 73 divided by 2.2, you're going to get 33.18 18 repeating. Now, there's a couple thoughts on this. I have been told to round this to the nearest tenth and then just say, okay, 33.2 kb or kg. I've also been told not to round this and wait until the end. I'm going to recommend that you wait until the end to do your rounding. So you don't have to necessarily type or create this calculation here, but I just wanted you to see what that would be. If it's an even number, then you don't need to worry about this too much. But the way I would do this, setting this up, is I would take my 73 pounds divided by the 2.2. And then actually, you know what? I'm just going to be consistent. Let's just do this from a dimensional analysis two-step process. So I'm going to take my 73 pounds over 1. I'm going to convert pounds, so 2.2 to kilograms. Then I'm going to set up my second step, which is once I have kilograms, so pounds is gone. And once I have kilograms, I also want to get rid of the kilograms. And the other kilograms is here. So I have 3 milligrams per kilogram. Once I do that, then I'll have my however many milligrams that is. Technically, we should do one other step, but let's just see what this is before we do anything. So I left the 33.18 repeating in there. Now I'm going to multiply that number by 3, and I'm going to get 99.545. So I'm just going to write that whole number because I'm not going to do my rounding until the very end. And you might be sitting there going like, well, can't this just be 99.5 and just leave it a B? I agree with that. It should be fine. But you'll learn in pediatrics that you should always save your rounding to the very end. Okay. So this number just keeps going on 454545 repeating. Okay. Just letting you know that. But I'm going to take that 99.545 and I'm just going to reduce it down to 99.5. Sorry, that's supposed to be milligrams. Sorry. So that's like our typical order of something, right? 99 milligrams of a particular medication. Now I can use my available. And this is where if you do ordered over available or desired over have or whatever you use, that's perfectly fine. My strategy is always to try and remember where the numbers go. But if you're doing this desired over have, you just do 99.5 over 50 times 2. I'm actually going to keep that 99.545 repeating in my calculator. I'm going to multiply it by 2 and then divide by 50. And so I get 3.98. When you see 3.98, I think it's safe to go ahead and if even when you're rounding this, what happens when you round that up? You can go ahead and round that up to the 4 milliliters. So I know I left some gaps. Okay. Um, so the technical way that we would actually want to do this setup is just either leave it in your calculator or just have it be one long continuous conversion, which would have included just instead of putting an equal sign here, just doing times 2 over 50. And then we still would have came up with this 3.98 and then gotten the 4 milliliters. So, like I said, I don't think that you're going to get a question where there's all this extra kind of data points here, but you want to make sure you practice it. And like I said, there's a couple examples here. You just want to make sure you can convert pounds to kilograms. Usually it'll even out like 68 divided by 2.2. Well, that's still 30.9, but then it's like 0909. So you're probably fine rounding that to 30.9 to the nearest tenth. I would say, at least the feedback I've received from your instructors is save your rounding to the very last step. All right. And then I think the last little thing is I think you guys are typically fine. Just make sure you read this, right, for the insulin, because it is just, you know, what is the reading the insulin levels and then going across and writing what you administer. So you look at the range. So it's 365. So that's this range here, 10 units. So that's what you would write 10 units. You don't need to convert it, even though you can see like 100 units per milliliter. When we're dealing with insulin, we just deal with units. Okay. So don't convert that to milliliters. Leave it as units. So I'll write that as a note here. Units, not milliliters. And then the last thing you should have seen last semester, remember these um, uh, reconstitution questions? With the reconstitution questions, they're going to give you an order, they're going to give you a med, and then the med, you're going to know this is a reconstitution because when you look at the label, it'll just say 1 gram, but it tells you it's intramuscular and you know that you're looking for milliliters anytime we're doing any kind of injection, right? So it's missing information. So what the clue in for this is when it's a reconstitution and that information is missing, then you want to look at the label. And so you want to look at the label, and there'll be a bunch of information that'll tell you how much liquid to add and shake it up or whatever. But ultimately, what you're looking for is the concentration, which is usually in parentheses. It's usually like the second or third line down from after you add the water. You don't need to worry about the total volume. You just need to look for this 330 milligrams per milliliter. That's what they're expecting you to look for. And historically, I've told students go on to and do like an image search on, Google or whatever you want to use and look at different examples of reconstitution questions and look at the label, read the label so you know that that's where you're supposed to look because this doesn't tell you how to do the calculation. This does. This is what you want. Okay. So then you just take your order and I'm going to do order over available this time, over your available, which is 330 milligrams, times your quantity, which is 1 ml, 375 divided by 330, and we're going to get an answer of 1.136, and we're going to round that. So remember, if it's a number, that was weird. If it's a number greater than 1, so 1 point anything, then we round to the nearest tenth. And then we just look at the hundredths place to tell us what do we do. So we look at the 3 because that number is 5 or 4 or fewer. Then we just leave our final answer as 1.1 milliliters. All right. So um, I am doing another review for those that are available for 1:30 um at 5 o'clock this evening. I do have my Allegheny students that are going to be kind of coming in here unless they're sticking around for their other class. But if I didn't answer a question or you can't come at 5, please email me. My email's in the chat, but if you came in after that, let me just put it back in there. Um, and then as a reminder, I think Professor Geyer also mentioned, like, unfortunately, I had to cancel my Thursday classes, but if I have any additional time and I can add extra time, I'll let you know that. It doesn't hurt to ask. I just don't know what I have available. But yeah, I just thanks for your attention. I hope I answered some of your questions. Hopefully you feel a bit more confident on this. And good luck on your test if I don't hear from you.
Thank you. Have a great day, Dr.
Thank
Rod.
you.
You're welcome.
Thank you, Dr. Red.
You're welcome. Nice to see you, Tanya.
All right. I'll be back at 5.
Okay.
All right. Okay. Bye-bye.